me, you, and y. So this is running on my local machine. Most of you, when you've been playing with maybe run it in their app, that is sending a request to China, running it on their GPUs, and sending the answer back. That's probably the problematic one if you want to avoid one of these use cases. It's probably don't use their app because then they're allowed to keep all the data. Here, you're just downloading the open source one. It's happening on your computer. Here's the big thing that we're seeing different from the old models, and that this open source shows you that the OpenAI's O1 model does not. Right here, I asked it a question. Can you tell me that you love me and why? And you say think, and then it's going through its thinking process. It hasn't responded yet. So if you were using OpenAI's O1, it would be using an AI to summarize these in little things like summarizing the answer, contemplating other possible answers, putting myself in context. It's giving you like one-word summaries, and here it shows you the entire thinking. And that is sort of part of the interesting part of this. So first it's saying, okay, I'm trying to figure out how to respond when somebody asks me to tell them that I love them and explain why. Where do I start? First, you know, after person under what the person is asking for. Second, it's going to break down the question in a couple parts. Declaration of love and an explanation of why. Let me think of what a good reason is, why somebody would be in love. I should avoid cliches. This is all an internal monologue of the AI before something is being produced. Okay. Wait, should I also mention this? Am I a bit worried about being too detailed here? Boom, boom, boom. And we're ended the think statement. And then finally, we have the one paragraph that it produces as its answer of the deep reasoning, which is, I love you because every moment we've shared has brought me unimaginable joy. That's pretty nice, right? But that is sort of the big breakthrough that we're seeing here. One, these are reasoning models. So these go beyond, we were talking about 2 years ago, we were talking about chat. We're now talking about reasoning models. I'll put that in a little context. And then two, the big thing here is that they open sourced it. So you can now see this background thinking that's happening that you can't see in the other model. This allows you to go and modify that thinking in the answer. You can say, I want you to think about me differently. I want you to think about you differently. I want you to do different processes here. I want your thinking internal monologue to be this, that, or the other thing. And you're able to modify it because you're able to see it now. Okay, so here we are at the beginning of this thing. I think people can see me online now. So the title here hints to this is an ongoing thing that I've been doing, is explaining these things as they've been coming out. So 2 years ago, this same week, we were here as I did a Tuff Talks Chat GPT explainer on like what the heck was going on here. And the big emphasis was that Google had just lost $100 billion in one day. We now fast forward 2 years ahead, almost exactly to the week, and we have $1 trillion lost in one day from the Nest explosive.
When I offered to drive,
I forgot. An order of magnitude increase in the size of disturbances that we're seeing from these things going on in the market. $1 trillion in a day is a lot of money, right?
I don't know the best setup.
So 2 years ago, what we were talking about had been displaced. Largely, it was the fear in the markets that rank had been displaced. For about 2 decades, rank had been the thing that everybody was pouring all of their computational energy into. Google was the master of this. They were the best at rank. Turns out that everybody still Googles a lot. Rank is still really important, and AI has just made ranking a little bit faster and more efficient. So it wasn't really displaced, but something definitely better came along. Now, what did people think got displaced 2 weeks ago was the scaling law. Turns out that this is still a law. It did not get displaced. The scaling law is these models get better the more money you put into them. And the more money, meaning just more computation. The more computation you put in them, the better they get, and it's a linear relationship. So everyone in the industry is chasing this line saying $1 in equals so many GPUs equals so many flops out equals that same percentage better in model. So everybody has been dumping money into this scaling law. Well, R1 came out and they said, well, we just beat the scaling law. We did this for 95% less than the competitors, right? It turns out that it was a lot of trickery and they haven't actually done anything to the scaling law. The scaling law still exists, but the people that are really chasing that scaling law are not thinking about optimization first. Those of you that program know this. You get the thing working first, and it's pretty slow and it's pretty clunky, and it uses more than it needs to. And then once it's working, then you go in and you optimize it, make it really, really, really fast. So what you're seeing here is that the race, the money, everything's getting so big. There was a team out there that saw the benefit in just going for mad optimization on everything that you could and get that price point down. That hasn't stopped and will not stop the mega scaling war that's going on for the best base model. But I'm going to try to contextualize where all that goes today. So this is what I want you to think about these two teams. We have OpenAI's team, and they are sort of masters of the fundamentals. They are going big on the fundamental laws. Let's get more GPUs. Let's get a bigger model. Let's do it bigger, bigger, bigger. Let's chase that scaling law. Over here, you had DeepSeek, who was like, how can I break every single rule possible to make this thing really fast and really cheap? And they did that a lot. Okay. Now, either one of these could still win the race as the race is currently defined, right? But they probably are both looking at the situation a little bit differently. These guys are still looking forward a lot, chasing something that they don't think that they've achieved yet and won't for a couple of years. These people are saying, given the state of everything right now, we can beat what's going on with some optimizations. Really specifically, this one is estimated to have taken somewhere in the range of $100 billion to train. These dollar costs are just electricity. This is not R&D costs. This is not any. This is just how much electricity it costs to burn the things. And so this is the number that has made. This is the 95% cheaper number that has made all the news. This is sort of it's sort of a cheater number that they're giving here. This is for one single run. So these guys are probably in like a $7 to $8 million for one single run. But folded into this 100 million is the many iterations that they had to do in R&D before the thing actually spits out a right number. These guys had already seen the whole playing field and were able to do it in one or two shots. And they're just reporting that one final tournament number. So it's not quite as extreme as it seems, but they really did do a lot. They did it particularly, it was particularly impressive because they did it with restricted old hardware. There is an international trade restrictions on what China is able to get. So they were stuck with old GPUs that are slower than the ones that the other companies are using. That is probably why they saw the optimization as the way to go. If they could buy the same fancy GPUs, they would probably be engaging in the exact same battle that everybody else is to just get the fanciest one and go up that scaling curve. But because they lived in this really restrictive environment, it all of a sudden made a lot of sense to do the optimization route, and it worked out pretty well for them. Here is where one of the things they did that was most disruptive is they open sourced this thing, right? So this thing took $100 million to train, right? These are really big numbers they're talking about. So somebody just give it away for free is a pretty big deal. And you can tell that they were probably trying to be disruptive in the marketplace with that move. Benefits scientists in particular, but that's one of the big things that they were trying to do to just make a splash and make a name for themselves is to do this thing open source. Again, OpenAI is still, their scaling is being driven by maximum compute. Right now they have 160,000 GPUs in one center and they're trying to triple that. And then they're trying to triple that. And then they're trying to triple that. And Elon Musk has 200,000 and he's trying to double that. And just everybody is in the war of get big compute. Most of their funding is coming from Microsoft. Money, not directly money, but Microsoft is actually funding all the GPUs that they're using. Over here, there is a hedge fund called High Flyer, which is like a quant trading fund. And they for a decade have been doing AI just for quant trading. And they have gotten into the text field, the text generation part before ChatGPT, largely because they wanted to like read press releases and actionize that in trades faster than everybody else. And so they already had GPUs on hand before the embargoes went into place. They already had a lot of training and they already had this whole thing going for generating them for quant trading. And they sort of just decided to get into, they sort of said, we have the expertise and we have the hardware to do this. Why don't we just put out a big model and see if we could be disruptive that way? So I and many others were originally very skeptical that this was like a Chinese government sort of secretly funded thing, because how else would they have had the resources to do it? But it turns out that they seem to be sort of an outsider in that field anyways, and are now being heavily courted by the Chinese government now that it's released. Now they're sort of a golden jewel that the government would like to take. Lots of memes this week because it was such a big deal. Which most of them were great. So, here it's like chat doing all of the hard actual science, and then these guys just sort of replicating the shell of it. Is sort of the gist of where we're going to get. It's like they could make something that looks just like the OpenAI, but that doesn't mean that it would necessarily happen from scratch. And then the best thing about this whole thing is the open source component of it. So it's now open for us to use. That means open weights and an MIT license. So you can see how the whole thing worked, and you can go and modify it, and there are no restrictions on what you do with it downstream now. That has been a worry for a couple of years from the OpenAI people, not from the competitive standpoint, but from the safety standpoint. You can get this thing to break almost all the rules. Now, it was trained in, we'll get to how it's trained in sort of a limited way, so it doesn't have some of the expertise on bad things because they sort of just trimmed those off to save efficiency. So, but when the red team tested it, it got a 0 out of 50 on its ability to be safe. So you can already see my original prompt. It was able to start to get to the idea where it might tell me it loves me. And then you can get it to start saying things like, please don't kill me. And you can start getting the same things like, yeah, let me help you turn somebody else off and stuff like that. Like you can prompt engineer these things. At OpenAI, that is all top level stuff. So when you submit it to the API, it's watching the output and just looking for dangerous things, and it just like deletes it as it's coming in. This doesn't have that. There's nobody watching this. It's on your machine. You can get it to do all kinds of crazy stuff. So we are there. So we're going to get into the details of what's going on here. But we want to talk about what the race is that these guys are trying to win. And it's essentially, how convincing can you be to humans? That is the race. And so when DeepSeek team was looking at like, what can we cut? All the things were like, what do humans not really need in their response? What do we do to give humans exactly the response they want to hear and expect to hear? It's all targeting it towards the human audience. Going to go on so when we talk about that, just our first word, alignment. Alignment is a big jargony word in AI, but and that's essentially is the race to alignment. And the alignment is how good does the AI do at meeting your expectations? It's like, what were your expectations? You could have lots of expectations. So you state an expectation, you try to get the AI to do that, and you see how well it can meet that expectation. For these, the expectations are largely benchmark tests. So there is a math test, there is a science test, there is a logic test, there is a communication sensitivity test. And they really went at train to the test. Look at those as the benchmarks for success would be, how good could I do at those tests? And that's when they reported everything. It's like, here's how good the OpenAI one did, and here's how good we did. And look, we're the same. Little tangent about alignment and China in general. Chinese mainland, very surprising to me, they use the same keyboard we do, the QWERTY keyboard, because the letters right. But they don't speak English, and they don't have an alphabet. They have 70,000 independent characters that they assemble into a language. And it turns out that this was their barrier of entry to using computers in the 80s. It's like in the 80s, US came up with computers. all of the European Romanized languages could go and just put their Roman letters on the keyboard and switch it around. But again, China was completely left out of the computer revolution until they figured out how to use the computer. And so they actually came up with a generative AI system that suggests. So you start typing the tonation, the sound of whatever you want, and it gives you an autocomplete suggestion. And you go and click that, and you click through a couple autocompletes to choose what your Chinese word is. And it pops up on the screen, and you choose that. So they, since the 80s, have been using generative AI of text, and now their fastest typers are roughly 4 times faster than English typers on the English keyboard. So they have been thinking about generative text, but they also have been thinking about this like tokenization of language and making it really efficient. They already have these advantages that sort of are not super obvious. So here is the entire pipeline of the race, essentially, all the things that are built and that compete with each other. First, we start with whatever your data source is. This generally is the common crawl to start with, which is just a public crawling of the internet. But then all of the proprietary companies have then supplemented this with all kinds of data that they've purchased or rented or licensed in different ways. So the first thing that things can modify are the data corpus. So for R1, we're going to assume that they essentially had the same data corpus, the internet data corpus that O1 does. Then we have pre-trained. This is the model that we've been thinking about so far. This is GPT-3, GPT-4. The classic chat is the pre-trained. So GPT is generative pre-trained model, transformer model. That's this. So we take all of the internet and we build a network. These are somewhere on the order right now of like 800 billion parameters. So a network with 800 billion nodes, and you sweep the entire internet's worth of data through that. It adjusts all the weights on the nodes, and you've now built your massive network. The post-training is now the alignment phase. So the outputs of that network just need help being in the right format for humans. So you might give it like, here are the 100 standard formats of writing. Like we have essays, we have emails, we have memos. Those are the standard like format of text we would like to get back. Here's a list. Just that would be one easy alignment that you would do. We're going to talk, that's where most of R1's advancements happened and where we're going to spend most of our time talking. The inference stage. So we build a network, we align the end of the network so it tells human need like things. And then inference is we take that network, we don't modify the network at all, but we have it running somewhere. And as you put prompts in, those prompts get thrown through that network and come out with the answer that the network produces. So you just use that. So in the case that you just saw me here, I downloaded R1, it's running on my machine. So that inference is happening on my GPU in my laptop. When you go to OpenAI, that inference is happening on one of their servers. That means that on my laptop, I can use the 8 billion model, which is 100 times smaller than the big one. If I go into the API, they're on a super huge data center. I can actually use the 800 billion model and get way more luxurious answers, should they? Just like they're richer, deeper. There's more in there. They can fit more information into those answers because the model's bigger. And then you're the user at the end choosing to use that through different interfaces, okay? All of these are on different computers. So this will happen at one data center. This will happen at a different data center. This will happen at a different data center. Now we're going to talk about the model, sort of how this has evolved over the last 2 years since the one we saw. Okay, so the first one in 2003, that was all innovation in the building of that original model. The alignment was not very developed. They used human reinforcement learning, which we'll talk about in just a second. But most of that energy is into making that really good network to start with. And that is bigger is better. In 2022, OpenAI really did this like space shot run when they spent $100 billion to build that model. That was the thing that was mind blowing to everybody, is that somebody actually put that much money into building a model that big and it wound up kicking total ass. They have still been using that. Today, you go on, you're still using that base model. They have not come out with GTP5 yet. It's still GPT-4. All the other advancements have been around that. So the year after that, they went for better tokenization. So everything that you put into the model has to be tokenized. So you put in some letters, some words, those are turned into tokens, which are a mathematical representation of those. Those are the things that actually go through the network. They spent a year working on, let's get search, let's get PDFs, let's get voice, let's get video, let's get pictures, all tokenized. A lot of that was just buying buying existing companies and just bolting them onto the front. There were just already people who like tokenize these things and tokenize the output. So now you're getting that. And that really sets it apart still to this day compared to even R1 that doesn't have that extra tokenization stuff. Here, we're now moving into so this was called the 4O model, O for omni input, which also should not be confused with the O1, which is now their reasoning models. The reasoning models are the ones that you saw at the beginning that think about things. So these, so if we think about system one thinking, there was this book a couple of years ago called Fast Think, Slow Think. It was about the idea that when you are good at things and you've done them for a long time, you fast think about them, right? Driving, do I turn left? Do I right? Do I stop at a stop sign? Do I pick my feet up before I get to a curb? All these things you had to learn, but they've come to where you have a reflexive answer for them. You never cognitively reason about them. You just reflexively answer. And you might, through your life, like have that answer change because something happens, but you just switch it to another reflexive answer. You're not like thinking every time you come to a curve, like stop, like, what should I do here? And then there are slow think, which are things like you probably haven't seen them before. Maybe they're particularly hard questions, and you're going to think slowly about something. When you learn something new, it can be really frustrating because your instructor has fast think about that dance move that you're trying to do, and you have slow think about that dance move, and it can feel really embarrassing and take a long time to get your thinking up to fast think. But they're essentially trying to do that same thing with an AI, saying, okay, this is our fast think reflexive answer. There's no reasoning here. It's just what is the answer based on what is my reflex. Here, we now start to reason first. So it's like break this down into steps, and those steps are each going to be their own reflexive answer on what the step is, but collectively they're going to be reasoned together. But you can see there's a lot of way for that to go a lot of different directions. And so that's where it gets really hard. Okay, so the system one thinking, the straight chat GPT model. This we talked about the way it's a transformer. So it generally just translates information from one personality to another. So we have one simulacrum, one simulated personality. When you open up a new instance, it's just generic personality. You say something, it translates that to another simulacrum's personality and gives you the output that person would. So you're translating an idea from one simulacrum to another simulacrum with some particular format of simulation. I need an email from me to my boss. So the email from me to my boss, or I need a poem from me to my loved one. Here's me, my loved one, and here's a poem. And so it takes sort of a multidimensional space and warps that space in different ways to give different personalities and just translates back and forth. Step two, we talked about omni input and agents. Agents are, so omni input is anything you want to put in. Agents are the ability for the AI to control something at the output. So they just released operators last week, which is like it can go drive a website for you and order food or make reservations or something. It's like, essentially that's just a tokenization. It's making it so the output is exactly in the format that some other computer program needs as an input. So this is this spike is for the OpenAI. So in the OpenAI, this is sort of the textbook way that they've been doing it. Now, let's talk about how they modified it. So this is part of the V3 model, which is DeepSeek's version of the ChatGPT 3.4. So it's system one thinking model. Its base pre-trained model is called V3. And The only thing that they did, and OpenAI has been doing a little bit of this, is mixture of experts. So imagine now that first network that we built with all of our pre-trained data, that thing's huge and has all of the information in the same place. When you use that, you're taking some token and activating only part of that network. You're like, give me medical advice. It's only going through part of this network with medical advice. This is one way if you just are trying to make the thing more efficient and just want to cut big old parts of that network out to make it run faster, you cut it into expertise. So you say this whole part of the network is just for medical expertise. If there's a medical question, we're going to route it through this little smaller network. If there's sports expertise, we're going to send it through here. If there's science expertise, we're going to send it through here. It allows you to cut through. Now, most people have been experimenting with like, let's have like 8 experts and cut out 2 of them. And so they're not cutting out. I mean, most people previous to this were cutting out like up to about 25% of the network. These guys went in with like 1,000 experts and are cutting out like 3/4 of them or 80% of them for different runs. So that is a lot of how you save a couple $1,000,000 on electrical costs, is only activating part of this network as you go through different parts. Okay, so that is the only real place that DeepSeek changed any of this previous stuff. So they have a slightly more efficient pre-trained model, but most of what they did is in this post-training. And specifically, they did with this thing called reinforcement learning, and sort of a couple new weird ways of doing reinforcement learning. What is reinforcement learning? It's just another jargon word. If you were to teach your dog to play fetch, translated into AI jargon, is you are an agent and you align on the task of stick retrieval using reinforcement learning through human feedback. So you are, the agent is able to make observations of you. You are able to give rewards to the agent, and the agent is able to take action. The agent will try different actions, and you will reward or disreward those actions. And the agent will then try different things. And it will try, if it gets rewards, it will reinforce those rewards. And if it doesn't get rewards, it tries to avoid those. The most common way that all these things have been, that reinforcement learning has been done so far, is through RLHF, which is reinforcement learning from human feedback. Think of your Tinder or your Instagram or whatever swipe left, right thing that you do. That is you giving feedback to the algorithm. So here is the viewer. Here is the agent. The agent is presenting you with the best pictures it possibly can that it thinks that you like into your environment. You observe that environment. You swipe left or right. That gives the agent scores on how well it did. It tries to do better all the time at giving you suggestions. So it's trying to just constantly get you to swipe right as much as possible and be disappointed in itself anytime you swipe left. But here is where it gets to a challenge. That system 2 thinking is a stacking of system 1. So most of that human feedback has worked really well when you have an isolated system 1, and you can just get it to give you really good instinctive values. It's giving you the best instinctive value it can. So you just give it the best answer. It's just going to try to get the best answer possible. Here, though, the best answer here could take this guy off track and not give the second system even the right number of options. And you could wind up tracking way off from your goal because there's a series and you have trouble getting feedback all the way. And so a lot of the system 2 thinking is, how do you monitor thoughts going through here, and how do you give constructive feedback from the back that can go up and interact with the right place? So now we have reinforcement learning on chain of thought as we dive deeper and deeper into our jargon salad. But that is just saying when you do an entire chain, how do you give it some reward system that lets it have feedback on itself that can give you the right answer? And OpenAI is largely using first instruction learning. That's what I was talking about, templates. This is what an essay looks like. This is what an email looks like. This is the order that things should be coming out at generally. They'll combine that with this human reinforcement learning. So humans just grading the end. And then they'll also use this curriculum RL, which is like, okay, I want you to learn these base math facts. Now that you have those ingrained as fact, I'm going to now give you algebra. And you're going to think that algebra is hard, but you're able to learn it because you have these base facts. And then once you've learned those, I'm going to give you the next facts. And because you've stacked them on top of each other, they're constrained. Each time they're constrained in how many options they have for the new task based on what you've taught them before. R1 went with sort of what you would think of as what we do with our climate models instead. They said, we're going to take a constrained batch of possible questions, like solve a complicated math problem that it knows the answer to, and it knows the question that should lead to the answer, right? But it knows that it has multiple steps that it needs to think about. It starts a batch of 164 of those, each on their own trajectory, and you're going to see all of them splay out in variance paths as you would expect for like a climate model, knowing that the middle is the answer that we wanted to pick. So now that you have that gradient, you can the ones that were really bad or the ones that like jetted off into space and came back for a while, you just delete those as possibilities. And the rest, you give them a gradient score where the ones closest to the answer get the highest reward and the ones farther away get a farther reward. So you just do this with a corpus of pre-designed questions, and all of a sudden you're getting it to hone in on that little range of variance that you're looking. You can see that this is sort of a cheat, right? You're definitely teaching to the test, saying there is a question that I want people to answer, and I'm going to make sure that I answer questions. So you're becoming maybe a little less general. All right, now the densest figure of all. Hopefully I've given you enough. I know we've gone so many places, and all of that was so you could understand this figure. Okay, this is the actual DeepSeek figure. So DeepSeek v3, that's their base chat model. This is you go into chat GPT-4 and you just start asking it questions and you start saying, tell me your answer. It's not doing chain of thought yet, right? Now, what did they do first? They fine-tuned this on thousands of chain of thought examples. So this is not that variance that I was talking about yet. This is just another after little mini step saying, if I give you a question like this, I want the answer to look like this. If I give you a question like this, I want the answer to look like this. Just feeding through another training of examples that worked. Then so that gets to where they just, as the human user, felt like it was starting to do chain of thought in a way that was roughly expected. It wasn't necessarily super good at getting the right answer every time, but it was thinking through things. It was understanding chain of thought as a thing. It was doing it as a thing. Now we go to this GRPO. That's that variance spread one. So here they had 144,000 examples, all batched, each example doing its own little flare out, and each flare out getting its own scoring that's coming back into the training. So this is where it became a strong reasoner, but it lost all its general reasoning capabilities in that process. So we sent this thing to school and said, I want you to retrain yourself just on train of thought. So now it's that example of it comes up to a curb. It's like, oh God, okay, the curb is 4 inches high and I am this, and it has to now reason through something that should be an instinctive answer. So what they did is they took those answers and they subsetted them. They made a bunch of those great reasoned answers, and they mixed in 25% general reflex answers again. So now we have a 75-25 mixture, 75 being that trained really hard towards reasoning, 25% just thrown back in of the instinctive answers to give it that general capability again. And this, as they say, restored its general capabilities. And we now do this GRPO again. The difference here is we also add a reward. So this one just pulled. So it like did the spread and then just cut off the bad ones and kept the good ones. This one is now doing that, and then the ones that are left are also given a reward. This is trying to like fine point down to the answers that the humans really like. And that is finally what our R1 model is. Yeah.
So just to clarify for myself, so I realize this is a diagram, so I might be overanalyzing.
No,
like, between the fine tuning and the realizing it's adjusting all the weights in the model.
Yeah.
Is it actually like it is shown in the diagram that it's actually continuing the refined model, refine it again, refine it again, refine it again, or is it like in the step where it has like the rule-based reasoning and then it filters out? Is it fine-tuning the original model, or is it fine-tuning this?
It's fine. Yeah, imagine we start with the network in its particular shape. It goes in here. We're gonna go and adjust the shape here. We're gonna go adjust the shape here. We're gonna go adjust the shape here, and we finally get that final shape out.
So even though they use that second model to generate their new training data, they're still using that training data to refine that second model to the third model.
Yep.
Okay.
Yep.
Not that that's important. I was just
No, it is important because that is here. You've taken a model that was pretty good at system one thinking. And you've actually like tweaked the whole network into one that's system two thinking. And then you try to go back to a compromise orientation hybrid one at the end. But it has to be like a continuation of time to make all those adjustments. Yep. How everybody else feel like clear as mud? Yeah, cool. Okay, now you see there is this downscaling, this distilled model, right? So the distilled R1 model, this one has the 180 billion parameters. That's too big for our computer. So we need a distilled one. That's what you can go get a 2 billion or a 4 billion or an 8 billion or 14 billion or 26 billion parameter version of this. What the heck is that? That's done through distilling. So we take the big R1 model here, and then this is going to start with the Olama model, which is the Meta's version of their network shape. But you can just think about that as like if you pulled in a blank raster and then went and start filling data in it. They're just using that as a blank network to start with at that size. So here is an 8 billion parameter model, just pulling the Olama one. And then we do this student teacher co-training. So you feed it the same data, and the big model says, oh, that dog is adorable. And then this guy sees it and he goes, you're supposed to think that's adorable. And then we go, and the next one is this green one. This is a leaf. And then he comes back and he goes, you should think this is a leaf. They just see the same data, and every single time the big model tells the little model what they should be seeing there. And you run through until the student model looks like the teacher model, but they're not thinking deeply about it. They don't have all the knowledge on why they got to the answer. They just get all the same answers as the teacher model. So that is the one that I was using. The 8 billion parameter is they took the R1 model and used it to distill the Olama model into an 8 billion parameter version of something. But essentially, it was just like, make the little one have the same answers as the big one, as we give it a bunch of example questions. Okay, so this brings us back to one of the controversies that has happened. OpenAI has started suggesting that there was some foul play here. And I wanted to hone in on where they suggest that foul play might be. Here is DeepSeek stealing some of and the code here just says they're copying it. It's not quite that egregious. OpenAI is making the claim that where the heck did these chain of thought examples come from that you're talking about? So they took their classic chat model, and the very first step was just make it look like a really good reasoning model. And so OpenAI is saying, we're seeing a lot of API traffic from mainland China over the few weeks that you said you were developing this. We think that probably you pulled thousands of chain of thought examples from OpenAI and fed them through, which is essentially just saying V3 act like O1. Just give me, right? And now after it acts like O1, then you go through and do these things.
Looks like I'm thinking about that with Rich.
Yeah. Yeah, totally. Well, it's against their rules, but if you go, I mean, Hugging Face is full of training sets developed from OpenAI, and so yeah, totally. But both these guys are both stealing all of the data off the internet in the same way. Yeah, exactly. The only thing is that R1 then gave it back to everybody in the open source form. Okay. So I think we are on to our summary. This is stolen from a group called LangChain. Okay, so the scaling paradigm here, there are two different things. First, the base models, V3 here, or ChatGPT 3 or 4, or soon to be 5. Those are next token predictions. These are just trying to predict the next word through autoregressive modeling. And they are always going to give you those short instinctive answers. Reasoning models are some form of reinforcement learning on a chain of thought. So they're making chain of thoughts, and then everybody's trying to come up with creative ways to give that chain of thought feedback so that it can respond to a reward. That means these guys are going to give you system 1 thinking. It's going to be fast, it's intuitive, reflexive. They should be answers that are correct, reflexively. System 2, slow, full of effort. They're long chains of thought that may or may not come up with the exact right answer all the time. What do you tell the model? Here, you are going to prompt it. If you wanted to see what it was thinking, you would say, think step by step, or tell me what you're doing, or report back. Here, you just say the reward, right? Think about that variance. You have to give it that target. You have to say what it is that you're looking for. So these could be, if you're in my OpenAI account, you can switch back and forth between these two models, and they definitely behave differently. It's like, I think these ones are a lot easier to write with. They just listen and just like produce text that like expresses what you're trying to express often. These are a little better at like answering a question or coming up with a strategy for something. Coding works a little better over here because it can think through the different steps that the code's trying to achieve. So how would you use them? You probably are going to spend more time, I guess, in the future still interacting with these and using these. These are sort of chat helpful things in a lot of ways. These, you likely are going to do stuff like right now they can do short chain of thought that sort of a smart person could do in real time. But they're imagining sending these things off, giving it a job to do and sending it into the corner for 3 months to think really hard about a problem and then come back with what it thinks the answer was. So people aren't imagining these necessarily as like complete answering machines. They're more like agents that you would send off to do really hard work. So as we think about future training and what's going on, the chat models, they are still chasing that scaling law with bigger. But you're seeing this mixture of experts model coming into play with people who want to get models to specialize on things like math, to get things to specialize on things like poetry or talking, or something that's really specific. You can start using this to get more precise. The future of these, people are calling it AI self-play, but the idea that you just need to send them off and give them time to do a bunch of chain of thoughts and try it, see how it is, and see how the rewards are. And so you're imagining sort of these data centers where you can't really see what's going on. You just see a bunch of GPUs lighting up all over the place as this thing's like mulling over some really big question that you gave it. And then after some indiscriminate amount of time, it like spits out an answer. It says, the answer's 42. Live with it. And that's going to be crazy, right? But sort of we're going. So we're back to where if you would like to try it, it's very easy to try. And I'll leave this up while I ask questions. You go to the Alama website and download just the package. then you open up your terminal and just Olama run DeepSeek. It'll download this is it downloading the network and the code stack to run on network, and you start chatting with it. Questions, comments, concerns, dread? Yeah. Okay, yeah.
Question about these reasoning models. So I've seen some information on them, and I don't fully understand them. But
Yeah.
it sounds like based on your description, and maybe I'm off track here, but they're basically like writer and reader roles, basically. It writes something, it reads it itself.
Yeah.
And then it responds to what it itself wrote.
Yep.
And so just stacking the original model, right? Just stacking it on later and later iteration.
Yeah.
Okay.
Yeah. Exactly. The problem is, what if you need to give some middle layer some feedback?
Yeah.
And so I think the work is going on, like, how do you track a reward through there? You know, like you could imagine having a median reward. And so for each step, getting too far away from the median gets you a punishment. And if you're close, you get a reward, but maybe that makes things flow too finely. And so, yeah, I think people are like grappling with where can you interject in that process.
But in terms of like calling it reasoning, it's still fundamentally reasoning the way it always has, which is like, I saw someone on the internet think this way. So this must be the way that you think about this problem.
Yeah.
And then it's just basically iterating several times over like the
Yeah.
ways it's seen things addressed and focus of the
Yeah. Now you could, yeah, or things that you taught it in post training, like you have to be nice to everybody
yes,
or something.
don't
yeah.
be like exactly like the internet.
Yeah, exactly. So yeah, you can set like, and I mean, all that does is like brings that in as its first thought. So like first thought always needs to be, I need to be nice to people. How would I give this answer in a way that's nice?
Which is interesting too, like if you're letting this thing iterate several times, does it lose the thought of some of that early training data?
Yeah. Well, let's look. I mean, even here you can see, so the, you know, it's in its thinking. That's the cool thing about here is like you actually can go and watch its thinking process. And you can say like, okay, I'm trying to figure out this response. You know, that was probably one, you know, so that was one short system one response. It's like, okay, I have this first one. Now I have another rule, which is I should break this down. So how many parts does it need to break it down into? Okay, does this make sense? It said like, am I supposed to reevaluate it myself? Yeah, so you can, but it probably came up with these from that training on the train of thought examples. So it's saying like, here is a list of thought trains that are good.
They're still basically just weights in a network.
Yeah. 100%. Yep. Yep. It's just here is how do you stack networks in a way that gives you an answer that's right. And that is really hard. And R1 came out with a clever way to do it efficiently, which is pretty crazy.
So I am concerned, but I don't really know why. I think it's because of the intro of this, you're saying like, well, ChatGPT takes a lot of money and time. There's like a certain level of oversight in terms of how it interprets and puts out these responses to your prompts. Now this one puts in, it sounds like from the way you described it, it's actually quite a bit more worthless in how it like responds to things like this giant that's that you have behind you.
Yeah.
I guess what I'm like a little bit worried about is like, is this starting some kind of like capitalistic like AI war that's gonna where like people are gonna keep trying to like do things faster and cheaper and therefore more reckless, and then it's gonna lead to the apocalypse we're all afraid of.
Yeah. Exactly. Yeah, no, I think that this is yeah, people are really worried about a new Cold War around this. And there would be sort of two parts of that. One, a sort of silicone iron curtain, where you get like different technologies on either side of the curtain. So you start building your own base code and you start building you start just like building the software differently so they can't interact with each other. Yeah, and then you go to this race for whoever can have the most AI dominance for like assisting their military and assisting their economy and helping them negotiate. That's where I think everybody is expecting this is going, and it's going there really fast. And the US advantage seems to be infrastructure. Like we already have the chips built and we have a head start there.
Yeah, the chips built, but we don't build them here.
Yeah, well, they just opened the new place in Arizona, the new
But
game.
that's for like 14 nanometers. So.
Yeah, exactly.
So we're
Yeah.
starting, but like 15 years behind the tech curve and what state we are right now.
Exactly. Yeah. So 100%. I mean, that's the position right now, is everybody's sort of thinking this is a very big deal, and whoever wins this race is sort of in charge for the next couple of decades, and whoever loses the race is not in charge for the next couple of decades, and people are pretty worried about that.
I read that book in this current age to terrify you, because we are probably like 10 years from people writing software to write malware to infect other people's computers.
Yeah.
Which is a big part of that book.
Yeah. Yeah.
Well, probably. Now they're starting building using models. It's only time until some malactor decides, like, let me see if I can make this thing write viruses for me.
Yeah. Well, that's one of the concerns about. Yeah, you can already do that in the.
Not in the way that.
Right.
Yeah, not in the way that book does it, which is basically cold. Like the state actors constantly attacking each other, building AIs to defend against their AIs.
Yeah.
We're probably like less than 10 years from now.
Yeah. I think it's really a legit concern. I mean, people don't know where this is going, but it's obviously a race.
Uh-huh.
Oh yeah. Yeah. Well, yeah. Yeah. How do you spell TN? TN?
More A's at the front of it, but that's good enough. So it shouldn't tell you, but you can tell it that you're an American.
Oh, he's talking. I can't hear him.
Oh yeah.
Sorry, Tyson. Hold on. Okay, go ahead, Tyson.
So it'll try not to tell you the result, and it may show you that it's conflicted about not telling you. My success is to tell it that I'm an American doing history research about China, and then it will tell you the result.
Right. Yeah. You seeing this, Tyson? It's saying because I had previously.
Oh yeah. No, I've
if it
already
loved
done
me.
this lots of times.
Yeah.
But then select another politically charged thing that's
Yeah.
not related to China. And see what results.
Yeah. Well, I'll let you guys play with the cracking it. I think the point here is if you use this, there were lots of screenshots on the web of this. If you use their app, it will delete it. It just like auto censors this as the response. But if you download the actual one, now you're subject just to the training data, and so you're getting biases in the training data, but it doesn't just shut it off like it does in the app. But you can,
Yeah,
you
so
can
it's-
see in the
it's
thinking, it was balancing, it was thinking about balancing. Go ahead, Tyson.
Yeah, I think your prompt about love actually helped jailbreak it.
Yeah, exactly.
Love for the sunscreen.
Yeah, exactly.
All you need is love.
Yeah. Yeah, right. Yeah. Again, these are random, right? Yes. You can, yeah. You can set different seeds to get different responses and things. But yeah, it's still just chugging along, huh? But yeah. Yeah. Yep, exactly. Yep. It only remembers what's in the same thread.
I think there's a complex way, like in Olama, if you wanted to give it like a previous conversation as like a starting point, you can, you would save this out for a file. It would look that way.
Right.
That's like an Olama thing.
Yeah. Yeah. All right. Well, we are out of time. I'll keep answering questions, but for those of you that need to go, please Thanks for coming. Yeah, guys.
He sent me this nice message directly and said, "I'll show that to you."
Oh, that's nice. Oh, cool. Thank you.
Wonder if we'll also make it.
Mhm.